This is by far the strangest and most thought-provoking experiment in physics. This diagram only shows the most basic information, but there is enough information here to explain the experiment. First, light is generated and passes through a double slit, represented by a vertical black line in the upper left-hand corner of the diagram. The photons go through one or both of the two slits, whose paths are shown as red or light blue lines, indicating which slit the photon came through. Red indicates slit A, light blue indicates slit B. So far, the experiment is similar to the conventional two-slit experiment. However, after the slit, a crystal converts the photons from each of the two slits into two twin or entangled photons. The light is then divided into two identical or entangled streams, one going upwards and referred to as the signal photon, and the other going downwards and referred to as the idler photon. In this way, the experiment is divided into two halves, the upper half and the lower half. The photons in the two halves are entangled and share information. The upper half is almost a normal two-slit experiment, and the detector D0 is the nearest to the two slits. Therefore, photons will always reach this detector first, before their twin or entangled photon reaches the detectors of the lower half of the diagram. The idler photon, represented by the red and light blue lines going downwards on the diagram, are deflected by a prism that diverts it onto individual paths, depending on whether it came from slit A or slit B. In this way, the two streams of light from slit A and slit B each come in contact with beam splitters represented by green blocks on the diagram. This creates the probability of a 50% chance of allowing the light to pass through and a 50% chance of causing it to be reflected. Because of the way the beam splitters are arranged, light can be detected by detectors labeled D1, D2, D3 and D4. Note that if it is recorded at detector D3, then it can only have come from slit B. If it is recorded at detector D4, it can only have come from slit A. But if the idler photon is detected at detector D1 or D2, it might have come from either slit, A or B. Therefore, which detector receives the idler photon either gives information as to whether the signal photon with which it is entangled went through slit A or B, or implies that such information is not available. At detector D1 and D2, the information of which slit it went through has been erased. By using a coincidence counter, the experimenter is able to isolate the entangled signal, recording only events where both signal and idler photons were detected. When the experimenter looked only at signal photons whose entangled idler were detected at D1 or D2, they found an interference pattern. However, when they looked at the signal photon whose entangled idler were detected at D3, or similarly at D4, they found no interference pattern. This result is similar to the double-slit experiment, since interference is observed when it is not known which slit the photon went through, while no interference is observed when the path is known. However, what makes this experiment so very odd is that, unlike in the classical double-slit experiment, the choice of whether to preserve or erase the information of which slit the idler photon went through need not be made until after the position of the signal photon has already been measured by D0. This is because of the shorter optical path from the two slits to detector D0. The data from this experiment has caused some to say that the delayed choice to observe or not observe the path of the idler photon will change the outcome of an event in the past being represented by the detector D0. But I believe the data only highlights that we have no fundamental understanding of why we have a past that can never be changed and a future that is always uncertain. In the next part of this video, I will explain a logical explanation of this experiment using a new theory in which light is a wave and only a particle when it comes in contact with the electrons of an object. This forms an interactive process with new photons continuously being formed relative to the position and momentum of the atoms. We see and feel this process of continuous energy exchange as the continuum of time, with the future coming into existence, photon by photon. This process of continuous energy exchange, or what I like to call continuous creation, will be within an infinite number of dynamic reference frames that are continuously forming, replacing previous reference frames as they become part of what we call the past. In this theory, light goes through both slits of the delayed choice experiment as a wave with a potential to be a photon if it comes in contact with an electron. Each photon that is recorded on detector D0 is a new moment in space and time in that reference frame. All of those photons that were recorded on detector D0 had the potential to form an interference pattern if the conditions had been right. In the lower part of the experiment, this potential was fulfilled for some of the twin or entangled photons. When an experimenter looks at the raw data at the detector D0, he or she will never see an interference pattern without using the coincidence counter. Therefore, it is very important to understand how this device works. The coincidence counter is based on time relations among data. Only by noting the timing of when the photon reaches detector D0 and then corresponding them with the timing of photons reaching detector 1, 2, 3, and 4 is it possible to sort the photon records collected by detector D0. When using coincidence information, what we see on the one single detector D0 is two interference patterns that we have in the lower part of the experiment at detector D1 and D2, superimposed on the same detector screen. This makes sense because two interference patterns at detector D1 and D2 are offset compared with each other. When one interference pattern peaks, the other valleys or troughs. Only when we divide the information into 4 groups will it become possible to see the interference patterns in 2 groups and only diffraction patterns in the other 2 groups. This makes logical sense because light has momentum and momentum is frame dependent. Therefore, each of the 4 detectors in the lower part of the experiment has their own reference frame, with time unfolding within each reference frame, photon by photon. The potential for this to happen was formed by light waves going through both slits of the experiment, with the potential to form future photon oscillations. This potential future, that is formed by the wave-particle duality of light, was recorded on detector D0. In this theory, called quantum atom theory, and artist theory on the physics of time as a physical process. The wave-particle duality of light is acting like the bits or zeros and ones of a computer, forming an interactive process, continuously forming a blank canvas that we can interact with, turning the possible into the actual. I will place a link here to a video that explains the complete theory. Thanks for watching. Please subscribe and rate. It will help the promotion of this theory.